everybody, Josh Rappaport here with Now I Get It Math. Today I'd like to present my third in a series of common algebra mistakes. And the mistake we're going to explore today is this one. X plus y quantity squared. A lot of students seem to think that this equals, you can probably guess, x squared plus y squared. Now, let's take a moment, as we always do, to have a little empathy for students and try to understand where they're coming from in making this mistake. So, in my experience in talking with students about why they make this mistake, what they usually say is, well, basically, I distributed the 2. I distributed the 2 to the x and I distributed the 2 to the y. So what they're doing is what I call over-generalizing. They're over-generalizing a property, the distributive property. Okay, and that's very understandable because here's the distributive property. 2 times the quantity of x plus y equals 2x plus 2y. The 2 does indeed, in a sense, distribute to both the x and to the y. Okay, now we have a couple different ways we can analyze this mistake and help students with it. So what I'd like to do is break this into 2 different points we can use. The first point, point 1, is to help students understand the difference between exponents and multipliers. By multipliers, I mean a number that comes either right in front of parentheses or it could come at the end of parentheses, but basically it's a number that is multiplying all the terms of the parentheses. It's multiplying the entire quantity of the parentheses. So students need to understand the difference between those 2 kinds of numbers, this 2 and that 2. All right, so how do we help them understand this? Well, here's one way to think about it. Multipliers, like the 2 here, act on the terms, okay? This is like in English when we're talking about a transitive verb, such as Joe shuts the window, Marge kicks the door, something's being done to something else. Or in the story that I'm going to elaborate on a little bit here, Mom dresses her tiny tots, okay? So we could think in this situation that in a sense x and y are kind of like the tiny tots and 2 is like the mom. So mom comes along, the 2 comes along and dresses tot x, and then mom again comes along and dresses tot y. So mom has affected tot x and tot y, and that's why mom is next to tot x and tot y. So mom has acted on both terms, and that's how you can think of a multiplier working. But exponents, on the other hand, work in a rather different way. So how do they work? Well, exponents basically tell the quantity what to do to itself. So now we can imagine that these little tiny tots have grown up, and now they're teenagers. And this is kind of a nice story to use when you're doing algebra because your students are generally teenagers. So when the tots have grown up and become teenagers, mom is no longer going to dress those teenagers. Instead, mom is going to tell the teenagers, she's going to say, hey, you two, get yourselves dressed. Dress yourselves. So now we can think of 2 as being the mom, and she's giving a command, and the command is, you dress yourselves. Do something to yourselves. So she's telling the quantity what to do to itself. And what she's saying, what that 2 is actually saying is, hey quantity, multiply yourself, and when you multiply yourself, put yourself down twice. So put down an x plus y here, and put down another x plus y here, because you have to put yourself down 2 times. Now, of course, we know that if that 2 had been a 3, we would have x plus y times another x plus y, because the command would be multiply yourself and put yourself down 3 times. So this gives us a new way to think about the power of the exponent, pun intended I suppose, that the exponent is giving a command to the quantity how many times to multiply itself. So we all have learned how to FOIL. I'm not going to explain the process of FOILing right now, but we know that if we take x plus y and we go ahead and expand it to x plus y times x plus y, we get x squared plus 2xy plus y squared, which is the correct answer over here. So I'm going to go ahead and write out what the correct answer is. But then we're going to explore this one other way, and we're going to explore it using the strategy now that we developed when we looked at mistake number 2. And that strategy is the strategy of plugging in numbers to check what the value of a variable expression actually would be. So what we're going to do here, we're going to let x equal 5 and we're going to let y equal 3, and we're going to do a couple of experiments. First, we're going to check out and see if what students at first thought was true. We're going to let them do this. So we're going to say, okay, let's check it out. If you think that x plus y quantity squared equals x squared plus y squared, let's try letting x be 5, y be 3. We'll plug in 5 for x and 3 for y on the left side and on the right side. So the left side we get 5 plus 3 squared, which is 8 squared, which is 64. And here's one way I like doing it. I like putting a little question mark over the equal sign, question mark, question mark, question mark. The right side we've got x squared becomes 5 squared, y squared becomes 3 squared. That would be 25 plus 9, that's 34. So we see that since 64 is not equal to 34, x plus y squared cannot possibly be x squared plus y squared. So that proves, in a sense, that there's no way that that thing that the students first thought was true could be true. X plus y squared cannot be x squared plus y squared. So let's let the students check and see if it is in fact equal to what we say it's equal to through foiling. So we'll do the same plug-in strategy, checking out if x plus y squared equals x squared plus 2xy plus y squared. So we know the left side by having done the plug-in here. We know that the left side is 64. We don't have to check that again. Plugging in 5 for x and 3 for y, we still have the 5 squared and the 3 squared, giving us the 25 and the 9, but now the middle term, the 2xy, becomes 2 times 5 times 3, that's 10 times 3, which is 30, so we get 25 plus 30 plus 9, which is 64, 64 equals 64, and voila, we see that, in fact, x plus y squared did equal x squared plus 2xy plus y squared. Now, of course, as I said before, it wouldn't be a bad idea, it would actually be a good idea to let students do this twice so they can verify it even more fully, get more comfortable and more confident with the idea that this is in fact the case. Sometimes students really like to depend on seeing things done with numbers, because numbers are in a sense the world that they're coming from. It's the world of elementary math. It's the world they trust, the world they know. So we don't want to underestimate the power of the world of numbers for students, even though they're in algebra. They trust that world, and it can be very powerful to let them check things out using numbers. So I suggest, doing that as much as students feel it's helpful. So in any case, that's my overview of this algebra mistake, this very, very common algebra mistake, some ways to understand why students make it, how you can help them think it through, and how you can help them see the truth of the situation, what x plus y quantity squared actually equals. And I'm just going to put up a few little practice problems so you can have students practice x plus y quantity squared and what it actually equals right after the video. As always, thank you so much for watching. Please feel free to share any comments that you might have, and feel free to subscribe if you have not yet subscribed. Take care, and I'll see you in the next video.